Welcome class 9. Today we will learn about the properties of magnetic field lines. The magnetic field lines have the following properties. Here you can see the the picture where the magnetic lines are coming out of the North Pole and going towards the South Pole. Okay, so they are the magnetic field lines are closed and continuous curves. Okay, they are continuous and they are closed curves. Outside the magnet, that is outside the magnet out here, the lines they are directed from North Pole to South Pole. So it moves from North to South Pole. Whereas inside the magnet they are directed from the South Pole to North Pole. So inside the magnet it moves from South to North Pole. Okay, and it moves outside as a from North to South Pole. That's why they are continuous curved lines. Okay. Number 4, the tangent at any point on a field line gives the direction of magnetic field at that point. Suppose if I say, let's find out the the magnetic field strength and the direction out here at this point. Let's say out here. Then we will draw a tangent at this point. That the tangent will be moving like this, straight away like this. So that particular direction will be the direction of the magnetic field on this particular point. So that will be given by the tangent of the field line at that particular point. Next is they never intersect one another. See over here, the lines will never intersect one another. If they intersect somehow, let's say that this line and the other line intersects each other, then what will happen? Then at that point there will be two directions shown by the magnetic line. Okay, because if the two lines are intersecting, that means they will be pointing out at two different directions. Okay, that means the magnetic lines, the direction will be shown in two different directions, which is not possible. So they will never intersect with one another. And also they are more crowded near the poles. As you can see towards the poles, okay, both at north and south pole, the magnetic lines are more crowded. Okay, that means the strength of the magnet is more towards the pole, and far separated near the middle of the magnet. Within this portion, the middle portion of the magnet, the magnetic lines are not that crowded and they are very far away. So this means that the strength of the magnet is more at the poles. Okay, towards the poles the magnetic strength is more, and less at the middle of the magnet. So over here the strength of the magnet will be less in between the poles. So at the middle portion the strength will be weaker. So that's why when any magnetic substances are attracted towards the magnet, they will be attracted towards the poles. Okay, because the magnetic strength of the poles are more or greater than the middle portion of the magnet. Now this is a line which is parallel. Okay, also they are also the magnetic field lines, but they are parallel and they are equidistant away from each other. Okay, then a uniform magnetic field is represented by this kind of line, by parallel and equidistant field lines. Okay, so this means that this kind of line represents that it's a uniform magnetic field.